A target hit is either going to be a direct hit, as in and this shows um, a single photon, but this is, again, as we said, is not going to be happening from single photons. These are many, many photons striking the DNA. In any case, a hit can be direct or indirect. Okay, a photon can directly interact with the DNA strand, and here's what's cool. The reason why X-rays can ionize DNA is because their wavelength, the length between, so you can see this wave, right? This is representing a photon. Photons are waves in the electric and magnetic fields, okay? That's, just accept that for now, and later in the physics class, we'll make it really, really explicit and help you understand what that really, really means. But right now, photon is a wave in the electric and magnetic field. Picture it as a wave, okay? The length from the crest of one wave to the crest of the next wave in a photon of X-ray is about the same width as the DNA strand is wide, okay? This is why X-rays can damage DNA, because their wavelength matches the width of the cell. This is why visible light cannot damage your DNA, okay? Because its wavelength is so long that it can't, a single wave can't interact with your DNA. The waves of the photon, the waves of energy, these electromagnetic waves, their wavelength has to be as wide or shorter than the width of the DNA strand in order to interact with it. If the width of that wave, my gosh, if the width of that wave is wider than the width of the DNA strand, a single wave cannot interact with that DNA strand. So that's why X-rays are harmful and other types of electromagnetic radiation are not harmful to the DNA. It's one reason why. So a photon can directly strike the DNA strand. Is there any reason why a photon would be, a photon traveling along its path, is there any reason why a photon traveling along its straight line path would ever be diverged into the DNA strand or pulled into the DNA strand towards it?
What was the
Would
question?
a photon of X-ray ever go from traveling in a straight line? Like you got over here, right? You've got a strand of DNA, okay? And over here you've got a nice clean path through the cell, okay? Is there any reason why the photon would go from its straight line path and be diverged toward the DNA? So it hits something else, right? So it scatters off of something here and then takes a straight line path towards the DNA. But what are the properties of X-rays? Like, what tells you about X-rays? What are their properties? They're light, so they travel at the speed of light. They have zero, no charge, right? X-rays have no charge, right? Electromagnetic waves have no charge. Do cells typically have a charge? Excuse me, I was terrible. Do atoms typically have a charge? That's what I was trying to say. Atoms can have charge, right? Atoms can be charged molecules. Most of the time they try to be neutral, but they have charge to them, right? Electrons, protons have inherent electric charge to them, right? A photon of light, or X-ray, has no charge. So there's nothing that can be attracting or repelling that X-ray photon. X-ray photons travel in straight lines. Francisco was clever, and he said, well, I think he already knew that X-rays travel in straight lines. So you go, all right, well, if we're going to get to over here from here, right, that X-ray photon has to hit something and then scatter that direction. But importantly, it's traveling in a straight line when it scatters, right? So X-rays cannot be attracted to the DNA. They just simply, they go along their path, and anything that they happen to run into, they run into, and they deposit all of their potential energy into that thing, into those atoms or into that molecule of DNA, if they happen to run into it. You are about 75% water. Your cells are mostly water, okay? The DNA in your cells only accounts for a small percentage, right? We said it was something like 1% of your cell's mass is given by the DNA in the cell. So if you're an X-ray photon, it's really unlikely that you're going to run into the actual DNA in the nucleus, right? If you're an X-ray photon, what is it much more likely that you're going to run into in the cell? What's the cell mostly made of?
Water.
Yeah, because you're mostly made of water, right? And you're made of cells. So it's way more likely that if you're a photon, you're going to run into water molecules, hydrogen and oxygen, right? Dihydrogen monoxide, right? Or H2O. I like to talk about it because it looks like a little Mickey Mouse ears. It looks like a little Mickey Mouse. So you're going to run into a bunch of these little Mickey Mouse ear molecules, okay? Water molecules. Now, water molecules are interesting because they're holding on. So the oxygen is the head of Mickey Mouse, and the hydrogens are the ears. And these hydrogen molecules are sharing electrons with oxygen so that they can complete their electron shells, and they can be removed from oxygen. They can be ionized fairly easily by X-ray photons. So it's way more likely that you're going to run into a water molecule if you're an X-ray photon. And then, again, we said because of the conservation of energy, if you're an X-ray photon and you run into a water molecule and you dump all of your potential energy into that water molecule, you can ionize the pieces of that water molecule. You can break that water molecule apart. Okay, you can break that water molecule apart into a single hydrogen atom and then a hydrogen and oxygen atom. Okay, hydrogen and oxygen molecule. You can create these ion pairs by ionizing water, by hitting water instead of hitting the actual DNA. So this splitting, this breaking apart of the water molecule is called hydrolysis or hydrolysis. Radiolysis of water is called hydrolysis. Okay, radiolysis just means, or radiolysis just means to use radiation to break apart molecules. Okay, in this case, this is the much more likely thing to happen in a cell. Okay, it's less likely for direct hits. It's more likely that indirect hits are going to take place in cells, ionization of water molecules. Ionization causes the chemical breakdown, lysis for breakdown, of water into ions and free radicals. So we're going to go ahead and talk about these ions and free radicals. You've heard about these, right? You've heard about free radicals, right? They're, you're told to like eat or drink things that have antioxidants in them because they destroy the free radicals, right? And you can find energy drinks, or not energy drinks, but like sports drinks that say that all the time, right? Anything that has the acai berry in it is said to be have antioxidants and have properties of eliminating these free radicals. Well, the problem with these free radicals is that they can change the DNA, the structure of your DNA, by ionizing your DNA. Okay, because they are effectively molecules that can pair up with DNA and change the shape of DNA. So even if it's not an X-ray photon, the energy from the X-ray photon can break apart water, and those broken apart pieces of water are themselves damaging if they're in the right spot in the atom. Now, if the DNA is over here and the free radicals and ions are way over here, well, of course, there's going to be no interaction, okay? But if it happens in the vicinity of DNA, then we worry about that. That's a problem. Okay, so free radicals. Free radicals are any uncharged atom with a single unpaired electron in the outermost shell.
Stay for a long time?
They're gonna try to neutralize. They're gonna try to neutralize. So they're gonna join up. That's the problem with them, is that they're on their own, free radical, right? And they're going to try to link up with another molecule. And if it happens in the right spot, it changes the shape of the molecule, and then that can hurt DNA, damage DNA. But no, they're because they're charged and the environment around them is not really. They're gonna try to neutralize very quickly. Go back to their ground state.
So they don't stay free radicals for long?
No, that's the problem with them, is that they go find something to join up with. Yeah. Um, Electrically neutral hydrogen atoms are free radicals.